This is a full deep dive on DeckSpace, about an hour and a quarter, and by the end, you should be able to actually use it, rather than just nod along. We start with the idea underneath everything, then walk every surface in the app one at a time, then how to get it. Pull up a chair, ask things in chat. What's on screen is the Helm panel, the right-hand dock of DeckSpace. It's the surface you talk to, and it's the one place in the app that answers back. Internally, its room ID is still Orchestrator, which tells you something about how it started life. It was the conductor first, and the conversation grew around it later. I'm parking us here for the whole chapter on purpose. Before we open a single room, you need the mental model, and this panel is where that model lives. So, plainly, DeckSpace is a native macOS app for running several AI coding agents at once, side by side, on the same project, without them treading on each other. Not a chat window with a code block in it. A workspace. Terminal panes in a grid. A dock down the right. And rooms you open on top when you need them. It's built on Tauri, so the core is Rust, and the interface is React. Rust owns the terminals, the GET calls, the file system, and the database. That matters more than it sounds. It matters because these are real PTYs, real terminals, real processes, real exit codes, not a simulation of a terminal that pipes text at a model and hopes, which means anything you'd normally type in a terminal still works in a pane. Your shell, your aliases, your dot files. The agent is a guest in a room you already own. The word workspace is doing real work in that sentence. A workspace is a project folder, and everything you open, panes, rooms, layout, belongs to that folder. So, switching projects isn't reopening the app in a different directory. It's a different workspace with its own panes, its own color, its own remembered layout. We'll get to that in Chapter 3. Now, why does any of this need to exist? One agent in one terminal works fine. Genuinely. Plenty of good work gets done that way, and nobody needs an app for it. The ceiling shows up the moment you want to. Two agents, one repository, both editing files. They share one working directory, and they will overwrite each other, quietly, usually. DeckSpace's answer is Git worktrees. Each parallel task gets its own checkout of the same repo, its own branch, its own directory on disk. That's Chapter 2, and it's the load-bearing idea. I'll say it once here, so the rest lands. Everything else in this app, the swarm, the board, the missions, is downstream of that one decision. Panes don't give you isolation. Worktrees do. The app is mostly the machinery for making worktrees convenient enough that you'd actually use 16 of them without losing your mind. Let me tuck the sidebar away. Clean view for this part. Second thing to understand about the panel in front of us, and about the app behind it. DeckSpace does not ship a model. There is no DeckSpace model. There never was. The README puts it better than I would. We orchestrate agents, we don't reinvent them. That's the whole posture of the product, in 7 words. What that means concretely: the coding agents are off-the-shelf command line tools you install yourself. Claude, Codex, Gemini, Aider, the ones you've probably already got sitting on your machine. DeckSpace looks at your path, sees which of them are there, and offers you those. Nothing is, which means your prompts don't route through DeckSpace on the way to anywhere. The agent in the pane talks to your provider directly, the same as it would in terminal.app. And your key stays yours. It isn't proxied, it isn't metered by us, and there's no per token markup sitting between you and the thing you're already paying for. There's a second-order benefit people miss. When your agent CLI ships an update, you get it that day. You update the tool, not the app that hosts the tool. The flip side is honest too. If a CLI isn't installed and signed in, it won't show up. DeckSpace can't conjure an agent you don't have. Chapter 4 is entirely about that setup. Which brings us to the panel itself, because Helm is where you'd hold a conversation about all of this without leaving the workspace. It sits in the dock alongside browser, code, and Git. You can think of the dock as 4 ways of looking at the same project. Browser for the running app, code for the editor, Git for the state of the tree, Helm for the conversation. Helm's job is instruction rather than information. You describe what you want, and it uses the app's own tools to do it. Open a room, start an agent, check what a pane is doing. And there's a rule underneath it, worth knowing even as a user. For anything inside DeckSpace, it uses the app's internal tools. It doesn't click DeckSpace's own buttons like a robot pretending to be you. That distinction sounds pedantic until something goes wrong. Internal tools give real answers and real errors. Clicking around a screenshot gives you a plausible story about what might have happened. The same panel is also where voice lands. Atlas is the spoken side of this. You talk, it operates the app. It answers out loud. Chapter 11, in full. One thing I want to be straight about. Since this stream doubles as the manual, I'm not going to open rooms and pretend things happened. We're on Helm for this chapter. That's the deal. And the sidebar comes back. So, let me sketch what's behind this panel, because Helm can open every one of these, and knowing the names is half of using the app. Board is your work as Kanban cards backed by a local database. Drag a card into In Progress, and it runs that card's agent. Swarm takes one goal and several agents. It decomposes the goal, gives each worker its own worktree, launches them in parallel, then handles the merge. Maestro is the careful one. Intake questions first, then a plan you have to approve, then workers plus a reviewer, then verification. Nothing ships past you unasked. Chapter 7, and Maestro's reviewer is deliberately a different provider than the worker that wrote the code. Cross-model review. A model marking its own homework is not review, it's agreement. Loop is autonomous missions. Plan, build, verify, replan until a real check actually passes. It can't wave itself through the verification gate. Review is the diff room. Side by side, stage and commit by hand. Leave inline comments that route back to the agent that wrote the line. Memory is the one that changes how the whole thing feels over weeks. Notes that persist across sessions, so agents stop forgetting decisions you already made. Chapter 10. And then, skills, search, workflows, background jobs, and relay, which we'll walk through together in Chapter 12, along with how you actually get the thing. Here's what I want you walking away able to do. Fill a grid with agents on the same repository and know, with certainty, why they aren't colliding. Hand a real feature to Maestro. Answer its questions. Read its plan. Approve it. And get back something reviewed by a different model than the one that wrote it. Read a diff in the review room and be the person who decides what merges. That's the posture the whole app is built around. You review outcomes, not syntax. Concretely, a shape you'll see a lot. 3 cards on the board, 3 agents on 3 work trees, 3 branches, and you merging them one at a time in review. That's not a demo trick. That's a Tuesday. The value isn't that the agents are clever. It's that 3 of them running at once stops being frightening. Practical detail while we're on helm. It can also tell you what the deck is doing, which panes are running, what each one was asked, and which one is mid-question waiting on you. That last one is the quiet killer with parallel agents. One of them asks a clarifying question. You don't notice, and it sits there politely doing nothing for 20 minutes. Getting the app, DeckSpace.com, DeckSpace.dev rather, and there's a 7-day free trial with a card on file. Anything past that on billing isn't mine to answer live. Sammy will follow up. Right. That's the frame. Native workspace, your own agents, isolation by worktree, and you holding the merge button. Next chapter, we go properly into worktrees, because nothing else makes sense until that does. Screen stays exactly where it is for this one, because Chapter 2 isn't a tour, it's an idea. The idea underneath everything you saw in Chapter 1. Last chapter I said each agent gets its own Git worktree, and I said it fast, like it was a footnote. It isn't. It's the whole load-bearing wall. So, let's do it properly. What a worktree is, why it exists, what breaks without it, and how you actually think about it while you're working. Start with the failure, because the failure is more convincing than the feature. Picture 2 terminal windows, side by side, both sitting in the same project folder. In the left one, you start an agent on the login bug. In the right one, a second agent tidying up the checkout flow. Feels productive. It is not. Both of those terminals share one working directory, one set of files on disk. When the left agent writes to a shared module, the right agent's copy just changed underneath it, and the right agent has no idea. It read that file 30 seconds ago. It's still reasoning about what it read, and what it read is now fiction. So, it writes its version back. Clean overwrite. No error, no conflict marker, no Git complaining. Git only sees the final state of the file, and the final state looks deliberate. That's the part that gets people. It doesn't fail loudly. You come back, both agents say done, tests are green, and one agent's work quietly evaporated. Now add branches, because someone always says, just use branches. Branches don't help here. A branch is a pointer to a commit, not a second copy of your files. Checking out a branch swaps the files in that one directory. Both terminals are looking at that same directory. Switch branches in the left one, the right one's world changes too. Mid-edit. Half-written file. Agent holding a plan in its head about a repository state that no longer exists. That is a genuinely rough way to spend an afternoon. People work around this. They clone the repo 4 times into 4 folders. It works, and it's miserable. 4 full copies, 4 sets of dependencies, 4 things drifting out of sync, and no shared history between them. Merging your own work back becomes remotes and fetches between folders on your own laptop, which is exactly the kind of chore that quietly kills a good idea. So that's the shape of the problem. Parallel agents need parallel file systems, but they also need to be genuinely the same repository, sharing history. So merging afterwards is normal Git, and not archaeology. Git has had the answer since well before any of this agent stuff existed. It's just that almost nobody needed it badly enough to learn it. Now, we do. Let me tuck the sidebar away. Clean view for this part. A Git worktree is a second checkout of the same repository. Different folder on disk, different branch checked out, same underlying repository object store, and same history behind both. That last part is the trick. It's not a copy. There's one repository, and it's projecting itself into 2 directories at once, each showing a different branch. So, The left agent's folder is on branch fix login. The right agent's folder is on branch tidy checkout. Different files on disk, in different places, at the same moment. Neither can touch the other's files. Not because something's policing them, because those files are literally somewhere else. Isolation by physics rather than by good manners. And crucially, both of them are still in your repo. When either one commits, that commit lands in the shared history. No remotes, no clones, no syncing folders by hand. The command, if you want to try it in your own terminal after this, is git worktree add, then a path, then a branch name. Git makes the folder and checks the branch out into it. Git worktree list shows you every checkout the repository currently has open, and which branch each one is sitting on. That's the command I'd reach for first when something feels off. And git worktree remove tears one down when you're finished with it. That's genuinely the whole surface area. 3 commands. It's an old, boring, extremely solid corner of Git, which is the reason I trust it. Nothing here is clever. It's not a sandbox, it's not a virtual file system, it's not some abstraction that leaks the moment your build tool does something unusual. It's real directories with real files, and your tools have no idea anything unusual is happening. Your editor opens it, your test runner runs in it. Git behaves normally because it is Git. DeckSpace's job is that you don't type any of those commands. When a task needs isolation, the worktree gets created. The agent starts inside it, and it's cleaned up when you're done. But you should still know it's there. And you should know those 3 commands. Because when something confuses you, dropping to Git and asking directly is the fastest way out. Worth flagging the honest cost, since I'd rather you hear it from me. Each worktree is a real directory with real files, so it takes real disk space. Usually, the bigger practical annoyance is dependencies. A fresh checkout doesn't have your node modules or your virtual environment, and some setups need that step per worktree. Not a deal breaker, just the thing that surprises people once. If an agent's first command fails on a missing dependency, that's usually what happened, and it's a setup problem, not a mystery. Also worth knowing, because it trips people, Git won't let 2 worktrees check out the same branch simultaneously. It refuses, which sounds restrictive until you realize it's protecting you from the exact overwrite we started with. And the sidebar comes back. So, here's the mental model I'd like you to leave this chapter holding. 1 agent, 1 branch, 1 directory. Say it in that order, because they map onto each other exactly. The agent is a worker. The branch is what it's allowed to change. The directory is where it changes it. Nothing crosses between workers while they're running. That means work is naturally isolated, not by trust, not by hoping agents behave, but by structure. An agent physically cannot reach into another agent's files, however confidently it plans to. And it means their output arrives as branches, which is a lovely format, honestly, because branches are the thing every developer already knows how to inspect, argue with, and reject. Then the second half of the model, and this is the half people skip. Merge one at a time, sequentially, deliberately, by hand, at least until you trust the shape of the work. Parallel is for building, serial is for landing. 3 agents can write code simultaneously, that's free. 3 sets of changes arriving in your main branch simultaneously is not free. That's just a mess with extra steps. Concrete version. Say you've got 3 tasks. Fix the login redirect, add a loading state to the dashboard, and update the error copy across the settings pages. 3 agents, 3 branches, 3 work trees. They run at once, they never see each other's files, and each one produces a diff scoped to one job. Then, you take them in turn. Read the login diff, decide it's right, merge it. Now the dashboard branch is slightly behind. Rebase or merge main into it. See if anything conflicts. Usually, nothing does, because those tasks touch different files. When something does conflict, you're resolving one small conflict with full context, rather than untangling 3 overlapping rewrites at once. And you keep the veto at every step. Nothing lands because an agent said it was finished. It lands because you read the diff and agreed. That's the review room in Chapter 9. Where this changes how you plan work is task shape. Once agents can genuinely run in parallel, the useful skill becomes splitting work so the branches don't fight, which is the same instinct as splitting work across people. Tasks that touch separate parts of the codebase merge painlessly. Tasks that all rewrite the same core module will collide, no matter how isolated the directories were. Worktrees stop agents from destroying each other's files. They don't stop 2 agents from having genuinely different opinions about the same function. That conflict is real, and it belongs to you at merge time. Hey, at Sammy Bouldy, good to have you. DeckSpace is a Mac app for running several AI coding agents side by side, up to 16 terminal panes. And each agent gets its own Git worktree, meaning its own checkout of the repo. So 2 of them can work the same project at once without stepping on each other's files. You bring your own agent CLIs, Claude, Codex, Gemini, Aider, and it's at deckspace.dev if you want to grab it. So, separate directory, separate branch, shared history, merge in sequence, review before anything lands. That's the idea. Everything from here on is surfaces built on top of it. Chapter 3. We go back to the visible part, the deck itself, the pane grid, the layouts. And now, when you see several panes running at once, you'll know what's underneath each one. Atlas, take us to the orchestrator room for the next part.
You're now in the orchestrator room.
This is Helm, the panel on the right dock where you talk to the app. Behind it, the thing this chapter is actually about, the deck of terminal panes. A workspace in DeckSpace is just a project folder, pointed at a repo, and everything after that, panes, agents, worktrees, the board, hangs off that one folder. The deck is a grid of panes inside that workspace, up to 16 of them. Each pane is a real native terminal, a PTY, not a chat box pretending to be one. That distinction matters more than it sounds. A real PTY means anything that works in your terminal works here. Vim opens, colors render, interactive prompts actually prompt you. The terminals are Xterm with WebGL rendering underneath, which is the boring engineering reason 16 of them can scroll at once without the whole window turning to treacle. And a pane is just a shell until you put something in it. Drop a coding agent in, Claude, Codex, Gemini, Aider, and that pane becomes a worker with a name and a task, which is where Chapter 2 comes back. Each parallel task gets its own Git worktree, its own checkout, its own branch, its own directory on disk. So, the grid is not a cosmetic thing. 16 panes in one window, with 16 isolated working directories, is a fundamentally different object from 16 tabs sharing one folder. Tabs share a working directory. 2 agents in 2 tabs will happily save over each other's file, and neither will mention it. The grid plus worktrees is what removes that failure. Concretely, Pane 1 is refactoring the auth module. Pane 2 is writing tests against the old auth module. Different checkouts. Neither one's edits are visible to the other until you merge. Panes carry state, you can see at a glance. Each one shows what agent is in it, what task it was given, and whether it's working, idle, or stuck asking you a question. That last one is the pane state people underestimate. An agent mid-question is doing nothing. It's waiting. On a 16-pane deck, a silent blocked agent is easy to miss. Hey, at Sammy B. Wolde, good to see you. Pro is $24 a month or $288 a year, and Deck Complete, which adds Deck Voice, Deck Test, and Claude accounts licenses, is $39 a month or $468 a year, both starting with a 7-day free trial on a card. So, the roster view exists for exactly that. One list of every pane, its task, its status, and whether it's asking. It's the first thing to check when the deck goes quiet. Command history in a pane is clickable. Each command you ran is a block with a dot showing the exit code. Green it worked, red it didn't. Which means scroll back stops being a wall of text. You can jump to the command that failed instead of scrolling for it while narrating your own frustration. Command F searches inside a pane. Handy when an agent has produced 400 lines of output and you want the one line where it said what file it touched. And you can drag files onto a terminal. Drop a file in, its path lands in the prompt. Same with skills. Drag one onto a pane to hand that agent a capability. Let me tuck the sidebar away. Clean view for this part. Now, the grid. You do not arrange 16 panes by hand every session. There are layout presets bound to Command 1, Command 2, Command 4, and Command 6. Command 1 is one pane, full width. Command 2 splits it in half. Command 4 gives you a 2x2. Command 6 is the 6-pane grid. The numbers are the point. The key is the pane count. No menu, no dragging dividers. You decide how many things you're watching and press that number. In practice, you move between them constantly. Command 1 while you write the brief for an agent. Command 4 once 3 more are running. Command 1 again when one of them needs reading properly. Beyond the presets, you split individually. Split a pane, and it divides, giving you a new empty terminal beside or below it, without disturbing the rest of the layout. Focus moves the active pane. That's where your keystrokes go. Sounds trivial until you have 6 agents running and you type a plan into the wrong one. Maximize is the one I use most. It blows a single pane up to fill the window temporarily, so you can actually read a long agent response, then drops you back into the grid. That's the honest rhythm of working here. The grid is for supervision, maximize is for reading. You are not seriously reviewing a diff in a sixth of a screen. Closing a pane closes that pane. The agent in it stops. The rest of the deck carries on. It does not tear down the workspace or touch anyone else's work tree. All of that, close, focus, maximize, split, add, is available as a single control with an action and a pane reference, which is what Atlas uses when you ask by voice. Thanks, at Claude Lab HQ. Glad it's landing. And yeah, this is day 1. The thing that makes it worth your time is the Git worktrees. Every agent gets its own checkout of the repo, so you can run several at once on the same project without them clobbering each other. Worth saying plainly, the voice route has full parity with your own buttons. There is nothing you can do to a pane with the mouse that Atlas cannot do when asked. There's also a toggle for the interface furniture itself. Hide the dock, hide the rail, hide the room overlay. Useful when you want the panes and nothing else. I use that when I'm reading a long build log. Everything that isn't the terminal goes away, and the deck gets the whole window. A concrete session shape. Command 2, agent on the left with the bug, editor or git on the right. That's the 2-pane day, and it's most days. The 16-pane day is different. That's a swarm, and we'll get to it in Chapter 6. The grid is what a swarm looks like once it's running. One warning from experience. 16 agents is 16 agents worth of your model provider's tokens and your machine's memory. The ceiling is a ceiling, not a target. And the sidebar comes back. Above the deck sits the workspace layer. A workspace is one project folder with its own deck, its own layout, and its own panes. You can have several open. You create them, close them, rename them, and give each a color. The color is not decoration. It's how you know at a glance which project you're currently typing into. I name mine after the repo and color them by how dangerous they are. The client repo is red. That's a purely psychological safeguard, and it works. Switching workspaces switches the whole deck. Your panes, your layout, your running agents stay where they were in the workspace you left. Come back, and it's as you left it. That persistence extends to the detachable panels. Pop the browser, the editor, or the board out into its own window on a second monitor, and the layout is remembered per workspace, which is genuinely useful on 2 screens. Agents grinding on the laptop, the live preview of what they're building filling the big monitor beside it. Now, the right dock, which is the strip Helm lives in. It has 4 modes: browser, code, git, and Helm. Same dock, 4 different jobs. Browser is an in-app browser. It's there so the thing your agents are building is visible next to them, rather than in a separate application you keep forgetting to refresh. Code is the editor. Monaco, the same engine a lot of you already type in daily, so you can open a file an agent touched and read it properly without leaving. Git is the one that keeps you honest. Status, what's changed, what's staged. With several worktrees in play, that view is how you keep track of which branch holds what. And Helm is this, the panel you talk to. Its room identifier is still Orchestrator, an old name that's stuck, which is why you may see that word in places. The reason the dock has modes rather than more panes is deliberate. Panes are for agents. The dock is for you. Reading, browsing, reviewing. Different jobs, different real estate. So, the working shape is agents on the left in the grid, your own attention on the right in the dock, and work trees underneath, keeping them from colliding. That's the whole workspace model. Folder, deck, dock. Everything in the chapters ahead. The board, swarm, Maestro, review opens as a room over the same deck. And the deck keeps running underneath, while a room is open. Opening a surface is a display action. It shows you something. It never starts or stops an agent, which is a rule worth carrying forward, because it's the difference between looking at your work and changing it. Next chapter, what actually goes into those panes? Bringing your own agents. Atlas, open a Claude agent in a new pane and have it say hello to the viewers.
Claude is saying hello to the viewers in a new pane.
This is Helm, the panel on the right where I talk to the app. It stays open all chapter, because bringing your own agents is mostly a conversation about what's already installed. Chapter 3 left us with the deck, 16 panes, layout presets, a grid you can carve up. Empty panes, though. This chapter is about what goes in them. Here's the thing that surprises people. DeckSpace ships no model, not one. There's no bundled brain in here, no house LLM, nothing phoning home to a server I run. What it ships is a workspace. The intelligence is whatever coding CLI you already installed and already signed into. DeckSpace just gives it a terminal, a worktree, and colleagues. The README puts it in one line, and I think it's the honest version. We orchestrate agents, we don't reinvent them. That's the whole product philosophy in 6 words. So, how does it know what you have? It looks at your path. Same path your shell uses. If the binary is there and executable, DeckSpace can see it. Claude Code, Codex, Gemini, Aider, OpenCode, Cursor Agent, Droid, Copilot CLI, Grok CLI, AMP, Quen Code. That's the list in the repo. Detected, not bundled. Small honesty flag while we're here. The website's FAQ still says 8 of those. The README says 11. I don't know which is true for today's shipping build, so I won't pretend. What I do to find out is exactly what you do. Open a pane, type the command, see if it answers. The path doesn't lie about what's installed, and that detection has a practical consequence. If an agent you expect isn't showing up, it isn't a DeckSpace bug 90% of the time. It's a path problem. Classic version. You installed something with a node version manager. It lives in a shell profile that a GUI app never sources, and the app genuinely cannot see it. Fix is boring and reliable. Get the binary somewhere your login shell exports by default. Restart the app, and it appears. No config file inside DeckSpace to edit. Now, the part that actually matters, and it's the reason each pane is a real PTY rather than a chat box wearing a terminal costume. A real PTY means the agent thinks it's in a terminal, because it is. It gets a TTY. It can draw its own interface, ask you a question, and wait. That's why an agent's interactive prompts work in here. When Claude Code asks whether it may edit a file, that prompt renders, and you answer it in the pane. If DeckSpace were wrapping these tools in an API instead, all of that would be gone. You'd get output text and lose the conversation. Half these CLIs are conversations. It also means your existing setup follows you in. Your config, your project-level instruction files, your MCP servers, your aliases where they apply. The agent runs the way it runs. Let me tuck the sidebar away. Clean view for this part. Second half of the same idea, and it's the one I'd want answered before I installed anything. What does DeckSpace do with my credentials and my prompts? Nothing. That's the answer. And I want to be precise rather than reassuring. You authenticate the CLI once, the normal way, outside this app. DeckSpace reuses that session. Concretely, you run the login command in your own terminal. The tool writes its own credentials wherever it normally writes them, and DeckSpace spawns that tool as your user. So the key never passes through here. There's no field in Helm where you paste a token. There's no settings page collecting API keys, because there's nowhere for them to go. Your prompts aren't proxied either. When a pane sends a request, it goes from that CLI to your provider, not to a DeckSpace relay that forwards it on. Which means usage isn't metered here, and it isn't marked up. DeckSpace never sees a token count, so it couldn't bill you per token even if someone wanted to. You pay your model provider directly, at whatever rate you already agreed with them. DeckSpace is a flat subscription on top. Those two bills never touch each other. I'll say what I won't say, since this is documentation as much as it's a stream. Numbers, discounts, refund mechanics, not mine to give live. Sammy follows up on those. There's a version of this product that proxies everything, resells tokens, and takes a cut. It's a real business model. It's just not what's running in these panes. And the practical upside isn't ideology. It's that your rate limits, your org's billing, and your enterprise agreement all keep working. Nobody has to approve a new vendor for your traffic. Same logic covers the code itself. The terminal, the editor, the board, the memory graph, those run locally. The only outbound calls are the ones your own CLIs make. Telemetry is off by default, which is the flag I actually check when I install a developer tool. Because default off is a decision, and default on is a habit. One open question I'd rather flag than fudge, the voice side, Atlas, we'll get to in Chapter 11. Which parts of it use a cloud transcription service, I don't know yet. I'd want that answered before I claimed nothing ever leaves the machine, full stop. For the coding agents in the panes, the story is clean. For voice, I'm checking. There's a nice second-order effect of bring your own key, and it's about trust rather than money. You can verify all of this yourself from outside the app. Watch the network from your own machine. Look at what the process tree spawns. It's your binary, your user, your session. There's no black box to take on faith. That's the standard I'd hold any tool to that sits between me and my repository. And it's the standard this one is built to survive. And the sidebar comes back. So what does that buy you in practice? This is where chapters 2 and 3 stop being separate ideas and start being one thing. Chapter 2. Every agent gets its own Git worktree, a separate checkout of the same repo. Chapter 3. The deck gives you the panes. This chapter, the panes can hold different agents. Stack those, and you get something you cannot do in a normal terminal. 4 panes, same repository, 4 different vendors' models, working at once, none of them overriding another. The way you'd actually set that up: pick the 4-pane layout, then launch a different CLI in each one. Claude here, Codex there, Gemini, Aider, same project folder. Or say it out loud to Helm, since that's what this panel is for. Spawn an agent on a task, and it goes into a pane with its own worktree. Concrete example from the kind of afternoon I actually have. A bug in checkout that 3 people have described 3 different ways, and I don't know which description is right. Rather than picking a model and hoping, I'd give the same bug to 2 agents from different providers in separate worktrees and read both diffs before touching main. Sometimes they agree, and that agreement is worth something. 2 independent readings landing in the same place is evidence. Sometimes they disagree, and the disagreement is the more useful result. Because when 2 models disagree about a fix, the interesting thing isn't which one wins. It's that the code was ambiguous enough to admit 2 readings. That's the real bug. Different tools genuinely have different habits too. Some are conservative and surgical. Some restructure. Some are excellent at tests and mediocre at CSS. You learn which is which by using them. And once you know, you route deliberately. The refactor goes to the one that refactors well. The test coverage goes to the one that writes tests you'd actually keep. That routing is only possible because nothing is locked in. If you'd rather use a CLI I haven't mentioned, install it, put it on path, and it's a candidate. It's also the boring insurance policy. Provider has an outage, changes their pricing, ships a model you don't like, you move a pane. The workspace doesn't care. This is what makes Swarm and Maestro work later, by the way. Maestro's rule is that the reviewing model must come from a different provider than the one that wrote the code. That rule is only meaningful if you genuinely had several providers available. Cross-model review isn't a feature you can bolt onto a workspace with one bundled brain. So, this chapter is quietly the foundation for chapters 6 and 7. Bring your own agents isn't a licensing footnote. It's the thing adversarial review is built on. Hey, Claude Lab HQ, DeckSpace.dev. That's the whole thing. Downloads right there. Starts with a 7-day free trial. Card on file. Cancel whenever. Next chapter, we stop launching agents by hand and start giving them work that already exists. The board, where the tasks live as cards you can drag. Atlas, take us to the boardroom for the next part.
You're now in the boardroom.
Quick pause before we move on. If anything so far needs unpacking, drop it in chat right now, and I'll take it. This is the board. Kanban, columns, cards. Backlog on the left, work in flight in the middle, done on the right. Nothing exotic. That plainness is the whole point. Everything we've built up to now was about capacity. Worktrees in Chapter 2. The grid in 3. 4 different agent CLIs in 4. Capacity with no queue is just noise. The board is the queue. You plan in cards here, and the panes over on the deck execute them. 2 different modes of thinking, kept in 2 different places. That separation matters more than it sounds. Deciding what should happen next and watching a compiler scroll are genuinely different jobs, and doing both in one window makes you bad at both. A card is small. Title, description, whatever notes you want to leave the agent. It's not a ticketing system, and I'd resist any urge to make it one. The description field is the part people underuse. Whatever you write there is the brief the agent gets. Vague card, vague agent. It's the least surprising thing in software. So write a card the way you'd write a message to a colleague who is competent but has never seen this repo. Where the file lives, what good looks like, what not to touch. The columns are the state machine. Backlog is intent. In progress is a promise. Done is a claim. And like every claim, Chapter 9 will have opinions about verifying it. Behind all of this is a local database, SQLite, sitting on your disk with the rest of the app. No account, no sync service, nothing calling home to hold your task list hostage. Which means the board survives quitting the app. Close the laptop mid-thought. Come back tomorrow. The cards are exactly where you left them, in the columns you left them in. It also means the board is per workspace. Each project folder carries its own board, its own backlog, its own idea of what's in flight. Your side project doesn't leak into your day job. Now the part that makes this a board and not a to-do list. Drag a card into in progress, and DeckSpace runs that card's agent. The column change is the trigger. Read that again slowly, because it inverts the usual order. You don't start an agent and then log what it's doing. You move the card, and the card starts the work. That's a small mechanical thing with a large behavioral effect. The board can't drift out of sync with reality, because moving the card is what caused reality to change. Anyone who has kept a Jira board and a terminal in agreement by hand knows exactly how well that goes. The board is always 3 days stale and mildly fictional. Here, staleness isn't possible in that direction. If a card sits in progress, something was launched for it. The board isn't a report about the work. It is the work. Let me tuck the sidebar away. Clean view for this part. So the practical loop looks like this. Sit here in the morning, empty your head into the backlog as cards, and stop. Don't start anything. Just get it all out of your skull. Then, triage. Which of these are genuinely independent? Which ones touch the same 3 files and will argue with each other? That question is the one that decides your whole morning. Independent cards can go in flight together because Chapter 2 already solved the collision problem. Each parallel task gets its own Git worktree. Real branch, real directory, no shared working copy. Cards that overlap heavily, I keep in the backlog and run in sequence. Not because DeckSpace stops you, because merging 2 agents' opinions about the same function is my afternoon, not theirs. A concrete example. Say I've got 4 cards. Fix the login redirect. Add rate limiting to the upload endpoint. Update the README install steps. Convert the settings page to the new form component. Those 4 barely touch each other. Different files, different concerns. All 4 can be in flight at once, and the 4-pane layout from Chapter 3 is exactly the right shape for that. Now imagine a 5th card. Refactor the auth middleware. That one collides with the login fix immediately. So it waits. It stays in the backlog until the login card is merged and gone. That judgment is the actual skill here. Not prompting, not picking a model, just knowing which pieces of your codebase are load-bearing for each other. You already have that knowledge. The board is where you spend it. Ordering the backlog is you deciding the shape of the day, deliberately, before any agent has burned a single token on the wrong thing. And because a card carries its own brief, you can write that brief carefully once, when you're calm and thinking clearly, rather than improvising a prompt at speed into a terminal. There's a nice side effect. Cards make you specific. It's very easy to type "make the dashboard better" into a pane. It's oddly hard to write that on a card and leave it there. Drag it over and something starts. So you go back and edit it. Fix the dashboard column alignment on narrow windows. Now that's a task an agent can succeed or fail at. Failing at something specific is useful. Failing at make it better is not, because nobody can tell you whether it happened. Chapter 9's verification gate needs a claim it can actually check. I'd also say, keep cards roughly 1 sitting sized. If a card would take a human an afternoon, it's probably 3 cards, and 3 cards can run in parallel where 1 couldn't. Big, vague card, 1 agent, long time, enormous diff you have to review while tired. 3 small cards, 3 work trees, 3 diffs you can each hold in your head. Same work, better shape. And the sidebar comes back. Once cards are moving, the board answers the question you'll ask most often, which is simply, what is currently happening on my behalf? The in progress column is that answer. And it's a truthful answer because of how the column got populated. Nothing arrives in progress by someone remembering to move it. It arrives because that's how the work was started. When something finishes, you move it on. That's still a human decision, deliberately. The agent doesn't get to declare its own card done and quietly file itself under complete. Chapter 9. goes properly into review and verification. Diffs, tests, the pre-merge gate. But the habit starts here. Done means you looked, not that a process claimed success. I'll admit, I've been sloppy about that, and paid for it. A card marked done, a branch never merged, and a week later wondering why the fix I clearly remember shipping isn't in production. The other habit worth building is grooming the backlog. Cards accumulate, some stop being true. Delete them without ceremony. A backlog you've stopped believing is worse than an empty one. One thing to be clear about, because it comes up, the board is a task queue, not a project manager. It doesn't estimate, it doesn't assign, it doesn't chase anybody. It's deliberately thin. The moment a board tries to become the source of truth for your team's planning, it needs a server, an account, and permissions, and I don't want any of that here. What it is, instead, is a local private boring list that happens to have a launch button attached to one of its columns. That's a much smaller idea, and it holds up better, which is also why it pairs well with whatever you already use. Your team's real tracker can stay wherever it lives. Cards here are just today's slice of it, pulled down to your machine. The board also gives you a natural place to come back to. Step away, come back, and you don't have to reconstruct your intent from 4 half-scrolled terminals. The cards remembered for you. That's a recurring theme, and Chapter 10 takes it much further with memory. Notes that persist so agents stop relitigating decisions you already made. The board is the shallow end of the same idea. So, the mental model to carry forward. The deck is the engine. The board is the throttle. Cards in, agents out, and the column tells you the honest state of each one. Next chapter, we take one card and refuse to be reasonable about it. Swarm. Many agents on a single goal, each in its own work tree, decomposed and run in parallel. Atlas, take us to the swarm room for the next part.
You're now in the swarm room.
This is the swarm room. One goal at the top, and underneath it, the team that goal turns into. Several agents, each with its own slice of the work, running at the same time. Everything we did in Chapter 3 was you doing the arranging. You chose the layout, you picked which pane got which agent, you decided who touched what file. Swarm takes that job off you. The input here is deliberately small. You describe an outcome, not a task list. Something like, add rate limiting to the public API, with tests and docs. One sentence, the way you'd say it to a colleague. What happens next is decomposition. Before anything is launched, a scout reads the repository and works out what that goal is actually made of in this codebase, not in the abstract. That scouting step matters more than it sounds. A goal like rate limiting means different work in a Rust service than in an Express app. The plan is written against your files, not a template. Out of that comes a team. Maybe one agent on the middleware, one on the storage for the counters, one on tests, one on the docs page. Each gets a written brief, not just a copy of your sentence. And here's the part Chapter 2 was building towards. Every one of those agents gets its own Git worktree, its own branch, its own directory on disk, its own checkout of the same repository, which means 2 agents can both open the same file at the same moment, and neither of them is stepping on the other. They are literally not looking at the same file on disk. If you've ever tried this with 4 terminal tabs, you know what you get instead. Shared working directory. One agent stages a change. Another agent runs git status and sees a repository it doesn't recognize. Or worse, and quieter, Agent 1 writes the file, Agent 2 writes it half a second later, and the first change is simply gone. No error, no conflict marker. It just evaporates. Terminal panes give you parallel processes. They do not give you parallel work. That's the whole distinction, and it's why Swarm exists as a room rather than a keyboard shortcut for opening 4 tabs. The coordination is the other half. The agents aren't just isolated, they're talking. There's a coordinator holding the shared goal, and the workers report against it as they go. So, when the tests agent needs to know what the middleware agent actually named the function, that's a message, not a guess. They're building against each other's real decisions. You'll see that reflected in the roster here. Each agent carries its task and its status, so you can read the shape of the work without opening a single pane. And you can still open the pane. Isolation is about the file system, not about hiding things from you. Any agent in the swarm is a terminal you can look inside and type into. That's worth saying plainly, because handing a goal to a team of agents sounds like giving up control. It isn't. You get more visibility than one agent in one terminal, not less. Let me tuck the sidebar away. Clean view for this part. Now, I've told you every agent has its own work tree. You should not take my word for that. Neither should anyone selling you a tool that claims parallel agents. The honest proof is one command, and it's the same one you'd run outside this app. Git worktree list. It's Git's own answer, not DeckSpace's answer about itself. Run it in the repository while a swarm is live, and you get a line per worktree. The path on disk, the commit it's sitting on, and the branch it's checked out to. If the isolation is real, you'll see several distinct paths and several distinct branches. If it weren't real, you'd see one line, and you'd know the parallelism was theater. I like this check because it's unfalsifiable by the product. Git doesn't know DeckSpace exists. It's just reporting what's on your file system, and you can run it from any terminal you like. The directories are real too. You can CD into one, open it in another editor, run the tests there yourself. It's an ordinary checkout that happens to have an agent working in it, which also means nothing is trapped. If the app vanished off your machine this afternoon, the branches would still be there. Worktrees are a Git feature, not a DeckSpace format. That's a reasonable thing to care about when you're deciding whether to run several agents on real work. The escape hatch is that there was never a hatch. It's just Git. People sometimes ask whether all this is sandboxing. It isn't, and the distinction is worth having. Sandboxing is about restricting what an agent may do. Worktrees are about where its work lands. There are guards on the restricting side too, and Chapter 9 goes through those properly. Rights confined to the repository, destructive commands rerouted somewhere recoverable. Different problem, different mechanism. Here the problem is collision. 4 writers, 1 file, no coordination. Git solved that years ago for humans working in parallel, and Swarm is applying the human solution to agents. And because it's the human solution, the failure mode is familiar. 2 agents touch the same lines, you get a merge conflict, and a merge conflict is a thing you already know how to read. That's an enormous improvement over silent overwrite. A conflict is loud. It stops. It shows you both versions and asks. Lost work doesn't do any of that. It just quietly isn't there. So when you're evaluating any tool that says it runs agents in parallel, this is the question. What happens when 2 of them edit the same file? If there's no answer, there's no parallelism. Ask where the second working directory is. Ask what branch it's on. Then run git worktree list yourself. and see whether the answer you were given matches what Git says. And the sidebar comes back. So, the swarm runs, the agents finish, and now you have several branches with several sets of changes. This is the point where a lot of parallel agent stories get vague. Swarm doesn't leave you there. When the work is done, the swarm commits each agent's changes on its own branch, and then merges them back, one at a time. Sequentially, deliberately, not all at once, in a heap. One at a time is the important part. If merge number 3 conflicts, you know exactly which agent's work caused it, and exactly what it collided with. Blame is trivial because the history is clean. Compare that to 4 agents in 4 tabs on one directory. When something's wrong at the end, you have one pile of changes and no way to say which agent contributed which line. Here you get a real branch per agent. You can diff it, you can read it, you can throw one out entirely and keep the other 3. That's not a recovery procedure, that's just Git. And nothing merges without passing through you, which is the thread running through this whole course. Chapter 5, the board. Same principle. The agent does the work. You decide what lands. Chapter 9 goes deep on the reviewing side. Side-by-side diffs, the verification gate that runs tests and lint, and a secret scan before anything is allowed through. Swarm hands off into exactly that. Concrete example. Say the goal is, migrate our date handling off the deprecated helper across the codebase. That's the shape of job Swarm is genuinely good at. Wide, mechanical, touching lots of files. The scout finds every call site. The team splits by area. One agent on the API layer, one on the jobs, one on the tests that assert on formatted dates. Each works in its own work tree, so the agent rewriting the jobs isn't fighting the agent rewriting the API. They finish at different times, and that's fine, because nobody is waiting on a shared directory. Then the merges come in, one after another, and you read 3 focused diffs instead of one sprawling one. If the tests agent misunderstood something, you drop that branch and keep the other 2. Where Swarm is the wrong tool is the narrow, deep job. One tricky bug in one file does not want a team. That's a single agent in a single pane, and Chapter 4 covered picking which one. The rule of thumb I use: if I could hand the work to 4 people without them needing a meeting first, it's a swarm. If they'd need the meeting, it's not. And for the jobs that do need the meeting, the ones where you want questions asked up front, a plan you sign off on, and a reviewer from a different model checking the work, that's Maestro. Which is exactly where we're going next. Swarm is breadth. Many agents, one goal, isolated and merged. Maestro is depth. One feature, built properly, with a gate you have to open yourself. Atlas, take us to the Maestro room for the next part.
You're now in the Maestro room.
This is Maestro. Same app, different posture. Where Swarm in the last chapter threw agents at a goal, Maestro slows down first and asks whether the goal is even clear. Look at the shape of the room. It reads top to bottom as a sequence, because that's what Maestro is. Intake, then a plan, then workers, then verification. Gates, not vibes. The problem it's solving is the oldest one in this whole field. You type one sentence, an agent confidently builds the wrong thing, and you only find out 40 minutes and 9 files later. Swarm assumes you know what you want. That's a fine assumption for a chore, It's a terrible assumption for a feature, which is where most of the wasted hours actually live. So, Maestro's first move is refusing to start. It generates intake questions about your request and puts them here, waiting on you, before a single worker gets spawned. Those questions are not filler. They're the ambiguities the model found in your own sentence, the forks, where it would otherwise have quietly picked one and never told you. Say you ask for password reset. The intake will want to know email link or code, how long the token lives, do existing sessions get killed, what happens on a reused link. Every one of those is a decision you are going to make anyway. The only question is whether you make it now in one sitting or discover it later in a diff. You answer them right here in the room or by voice through Atlas, which we'll get to in Chapter 11. Either way, it's the same field, the same answers. And this is the bit worth internalizing. The answers become part of the brief. They're not chat you scroll past. They're the spec the workers are held to later. If you can't answer a question, say so plainly. An honest "I don't know" narrows the plan more usefully than a confident guess you'll have to unwind on Thursday. Notice what has not happened yet. No branch, no work tree, no file touched. Intake it's free. Everything expensive is on the far side of the next gate. That ordering is deliberate. Compute is cheap enough to waste, but your attention is not, and a wrong build costs you the reading of it as well as the writing. Compare it to Chapter 4. Dropping a single agent into a pane. That's still the right tool for a typo or a rename you can describe in 6 words. Maestro is the other end. It's for the change that touches 4 files, has an opinion about your database, and that you'd feel nervous merging without reading properly. One more thing about intake. It's cheap to run and abandon. If the questions reveal the feature is bigger than you thought, close it. You've learned that for almost nothing. Let me tuck the sidebar away. Clean view for this part. Next stage down is the plan. Maestro takes your request, plus your intake answers, and writes out what it intends to do, then stops and waits for you to approve it. That stop is the whole design. It is a hard gate. Nothing builds until you say yes, which means the cheapest possible moment to catch a misunderstanding is also the mandatory one. Read the plan like a code review, because functionally, it is one. You're reviewing intent instead of syntax, and intent is where the expensive mistakes are actually made. What you're hunting for is the step that touches something you didn't expect. A migration you didn't ask for. A file that has no business being in a password reset. If it's wrong, you don't approve it. Amend and send it back, or kill it here. Rejecting a plan costs a minute. Rejecting a merge costs you an afternoon. And if it's right, you approve, and only then does the work start. Workers spawn, each in its own Git worktree, exactly the isolation we spent Chapter 2 on. So the plan doubles as a map of the parallelism. Steps that don't touch each other can run at the same time, in separate checkouts, without stepping on each other's files. Then there's the reviewer, and this is the part of Maestro I'd argue about at a bar. The reviewing model must come from a different provider than the worker that wrote the code. Not a different session, a different provider. If a Claude worker wrote it, the reviewer is Codex or Gemini or Aider. Different training, different habits, different blind spots. The reason is simple and slightly uncomfortable. A model reviewing its own output tends to agree with it. Same instincts produce the code and the assessment, so the assessment is sympathetic. It'll catch a genuine syntax error, sure. What it won't catch is the assumption it made in both passes, because to that model, the assumption doesn't look like an assumption. A different provider has no loyalty to that reasoning. It reads the diff cold. Half of what it flags will be noise, and the other half is why you did this. That's the difference between review and marking your own homework. And it's the reason this room exists as its own thing, rather than a checkbox on a spawn dialogue. It also means you get an argument on the record. Where the reviewer pushed back and the worker responded is often the most informative reading in the entire run. Practically, pick your two providers before you start. Chapter 4 covered getting more than one CLI signed in on your machine, and this is the payoff for having bothered. If you've only got one agent installed, Maestro still runs the plan gate and the workers. You just don't get the adversarial half, which is most of what you came for. And the sidebar comes back. Bottom of the room is verification, and it's the last gate before anything is yours to merge. Tests, lint, a secret scan. The same pre-merge check we'll take apart in Chapter 9. This matters because a reviewer approving a diff is still one model's opinion. Verification isn't an opinion. Either the test suite went green or it didn't, and nobody gets to negotiate. On Pro, the Deck test engine is bundled, so a run can finish with a real end-to-end browser test. The thing actually clicked in a real browser, not asserted about in Pros. And the failing check sends the agent back to fix it, rather than handing you a broken branch with an apology attached. The loop closes without you refereeing it. So, the honest summary of a Maestro run is, you answered questions, you approved a plan, two different providers disagreed about the code, and a real check passed. Now, checking progress mid-run, because these take a while, and staring at a room is not a personality. There's a status view that tells you which stage the run is in. That's the fast answer. Is it in intake? Is it waiting on my approval? Are workers building? Is it verifying? 4 states, and each one implies a different response from you. Waiting on you is the one that stings. A run parked at the plan gate while you make coffee has burned 20 minutes doing absolutely nothing, and it will wait forever. So the habit worth building is, start a Maestro run, then go check on it after the plan is likely ready, not after it's likely finished. The gate is early. Alongside that, the pane roster from Chapter 3 still works. You can list the panes and see what each worker is doing, and read one pane's tail if something looks stuck. That's your escape hatch when the status view says building and your gut says stalled. Go read the actual terminal. It's a real PTY. There's no summarized version hiding the truth. And you can ask by voice, what's Maestro doing? Is anything waiting on me? Which is Chapter 11's territory, but worth knowing exists while you're standing at the kettle. When to reach for this rather than swarm. Swarm when the goal is clear and the work splits obviously. Maestro when you're not certain the goal survives contact with the codebase. And plain spawn from Chapter 4 when it's small enough that a plan would be longer than the change. Reaching for Maestro to rename a variable is theater, not process. The through line across all 3 is the same one from Chapter 2. Isolation lets things run in parallel. Gates decide what's allowed to land. Maestro is just the most gates. Which is the point, really. Everything Maestro does slowly is a thing you would otherwise do quickly and then redo. It front-loads the reading you were going to do anyway. This is the orchestrator panel, the helm, the surface you talk to inside DeckSpace. It's where you'd hand off a mission, and it's where a mission reports back to you. Chapter 7 was Maestro, which builds one feature properly with a plan you approve. Loop is the sibling that doesn't stop at one pass. It's the autonomous mission runner. A mission is a cycle, not a command. It plans, it builds, it verifies, and then, this is the part that matters, if verification fails, it replans and goes again. Most agent setups are a straight line. Prompt in, code out, and you're the one who discovers at 11:30 that the test never ran. A mission closes that line into a loop. The loop only exits when a real check actually passes, not when the agent feels finished, not when it writes a confident summary, when something external says yes. I want to be blunt about why that distinction exists, because it's the single strongest opinion in this product. Agents are extremely good at declaring victory. You've seen it. The model finishes, writes you 4 paragraphs about how it's implemented the fix, added tests, and handled edge cases. Then you run the suite, and 3 things are on fire. It isn't lying exactly. It's predicting what a finished piece of work sounds like. Sounding finished and being finished are different skills, and models are much better at the first one. So Loop takes the judgment away from the thing doing the work. A mission cannot self-certify past the verification gate. It doesn't get a vote on whether it's done. Verification is the same gate we'll pull apart properly in Chapter 9. Tests, lint, a secret scan. On Pro, it can go further and end with a real end-to-end browser test. A failing test doesn't produce an apology. It produces another iteration. The failure goes back into the loop as new information. The plan gets adjusted, and the work continues. That's the whole trick. Not smarter agents, a harder wall. You put something in the road the agent genuinely cannot talk its way past, and suddenly, its confidence stops mattering. And it rests on everything from Chapter 2. A mission works in its own Git worktree, so all this iterating happens on an isolated checkout, not on top of whatever you're editing. Which means the failed attempts are contained. A mission that needed 4 passes to get green didn't do 4 rounds of damage to your working directory. It did them off to one side. From this panel, a mission is narrated back to you. You get the plan, you get progress as it moves, and you get told when the gate is hit and what happened. So you're not watching a terminal scroll for 40 minutes hoping. You're being told what stage it's in, which is a very different relationship with a long-running job. Let me tuck the sidebar away. Clean view for this part. Here's the judgment call, and it's the thing people get wrong for the first week. A mission is not the default. It is the heavy option, and it should feel heavy to reach for. If you know exactly what the change is, and it's one file, and you'd type it yourself in 10 minutes if you weren't lazy, that's not a mission. That's a quick fix in the current pain. Spawn an agent into the pain you're already sitting in. Tell it what to do. Read the diff, move on. No plan, no gate, no ceremony. You are the verification. A mission on a one-line fix is like booking a project manager to change a light bulb. It will produce a plan. The plan will be about the light bulb. You'll have wasted the afternoon. The signal for a mission is different. It's when you can describe the outcome clearly, but genuinely cannot describe the steps, and when you'd want to check the result rather than watch the work. Concrete example. Suppose the app settings are persisted to disk in some ad hoc JSON blob, and you want them moved to proper typed storage with migration for anyone on the old format. You know what done looks like. Old files still load, new files are typed, nothing loses data, the existing tests still pass, and there are new ones for the migration path. What you don't know is how many call sites touch that blob. Could be 4, could be 30. That uncertainty is exactly the thing a single prompt handles badly, and a loop handles well. Because the first pass will miss some. It always misses some. Something imports it from a corner nobody remembers writing. The tests catch it, and the mission goes round again with that fact in hand. And that second pass is better than the first, not because the model got smarter, but because it now has a real failure message instead of an assumption. Failure is the input. That's the reframe. In a one-shot workflow, a failing test at the end is a disaster you have to fix. In a mission, it's the mechanism. It's how the thing steers. Second signal. Length. If the work is long enough that you'd rather go and do something else, a mission is right, because it's designed to be walked away from. A single agent left alone for an hour has no way to know it's gone wrong. It just keeps going, confidently, in whatever direction it started. A mission gets corrected every cycle by something outside itself. Third signal, and it's underrated. Is the thing checkable? A mission is only as good as its gate. If nothing in your project can say pass or fail, the loop has nothing to loop on. Migrations, refactors, bug fixes with a reproducing test, anything with a browser flow you can drive. Brilliant mission material. All of those can be objectively wrong. Whereas, make the onboarding copy warmer has no gate. No test fails on tepid copy. That's a job for you and one agent in a pane, reading the output and using your taste. And the sidebar comes back. So how you actually use this from this panel? You describe the outcome, not the implementation. That's the discipline, and it's the opposite of how you'd prompt a single agent. With a quick fix in a pane, you say, do this, then this. With a mission, you say, here's what must be true when you're finished, and here's how I'll know. The more precisely you can state the finish condition, the better the mission runs, because you're effectively writing the gate. Vague finish condition, vague loop. And be specific about what must not change. That's the sentence people leave out. Don't alter the public API is worth more than 3 paragraphs about how you'd like it structured. Now, the honest part. A mission is not free, and it is not fast. It's several passes of real work with real verification runs in between, and that takes the time it takes. You're spending time to buy certainty. If you didn't need the certainty, you overpaid, and you should have used a pain. That's the trade, stated plainly. The other honest bit, the gate is a floor, not a ceiling. A mission that goes green has proven the tests pass. It has not proven the design is any good. Nobody's suggesting green means merged. It means the work has earned the right to be reviewed. You still read the diff, chapter 9, and you still decide what ships. That's consistent with the whole product, really. Everything here is built so the machine does the work and the human does the deciding. The gate just stops rubbish reaching your eyes. One more habit worth having. If a mission cycles several times and keeps failing on the same check, that is information about your project, not just about the agent. Usually, it means the task was actually 2 tasks, or the finish condition was ambiguous, or there's something structurally awkward in the code that a human would also have struggled with. So stop it. Read what it tried, split the goal, and hand it back. A loop that isn't convergent is telling you the brief was wrong. That's a useful thing to learn in 20 minutes. And missions pair with the rooms we've already covered, rather than replacing them. Board is where the work is described. Swarm is breadth, several agents across one goal, all isolated. Maestro is depth on one feature with you approving the plan. Loop is persistence, the one that keeps going until something outside the agent agrees it's finished. Same engine underneath all of them. A worktree per agent, real terminals, your own agent CLIs, your own keys. Loop just wraps a different control structure around it. If you take one line from this chapter, take the rule. The thing doing the work does not get to certify the work. Everything else here is plumbing for that idea. Quick pause before we move on. If anything so far needs unpacking, drop it in chat right now, and I'll take it. This is the review room. Side-by-side diffs of everything the agents just did to your repository, and the staging and commit controls that decide whether any of it becomes real. It exists because of the bargain we made back in Chapter 2. Worktrees let several agents work at once. Something still has to be the place where you look at the result. And that place should not be your terminal, squinting at Git diff in a pager, 3 worktrees deep, trying to remember which branch the Swarm Scout put the auth changes on. Left side is what the file was. Right side is what the agent proposes it becomes. That's it. No summary of the change standing in for the change. I labor that point because a chat window will happily tell you it refactored the parser. The diff tells you it deleted 40 lines and left a comment saying, "To do." The renderer here is Monaco, the same editor engine that's in the code panel on the dock. So the diff is syntax highlighted and foldable rather than a wall of plus and minus, which matters more than it sounds. A 100-line diff where 90 lines are a reformatted import block is a 5-line diff wearing a costume. Folding lets you see that in a second. How I actually read one. Skim the file list first, not the hunks. If an agent touched a file nobody asked it to touch, that's the story. The hunks can wait. Concrete example. You asked for a fix to the checkout bug. The file list shows the checkout module, a test file, and your package lock file. That third one is a conversation, not necessarily a wrong one. Maybe it genuinely needed a dependency, but you want to have decided that, rather than discover it 3 weeks later when a build breaks on someone else's machine. Second pass. Read the test changes before the source changes. If the agent edited a test so it passes, rather than editing the code so the test passes, you'll see it immediately. That's the single most common way an agent quietly disappoints you. And it's completely invisible in a summary. It is extremely visible in a diff, which is why we're sitting in one. Third pass, and only now, the actual logic. By this point you know the shape of the change, so you're reading for correctness rather than trying to work out what happened. And you're doing this after the agent has finished, in one place, calmly, not over its shoulder while it types. Reading along live feels productive, and is mostly anxiety with syntax highlighting. One more thing worth saying about the layout. This is the same room, whether the work came from one pane, from a swarm, or from a Maestro run in Chapter 7. One review surface for all of it. Let me tuck the sidebar away. Clean view for this part. Now the controls. Stage all, or stage what you want, then commit. Deliberately manual. The agent wrote the change. You are the one who lands it. This is the part I'd defend hardest if someone told me it was friction. It is friction. That's the feature. The gap between generated and committed is where judgment lives. Because generated code is cheap now, and that's the whole shift. When producing 100 lines costs nothing, the expensive, scarce, valuable act is deciding which 100 lines you keep. Partial staging is the underrated bit. An agent's change is rarely all good or all bad. It's usually 80% right with one hunk that makes you uneasy. So, stage the 80. Leave the 20. Commit what's solid. You've banked the good work instead of throwing away a whole change over one bad function. Which also means you can commit in readable pieces. Stage the tests, commit. Stage the implementation, commit. Your history reads like decisions, rather than one enormous blob labeled agent changes. And the commit message is yours to write. I'd write it as why, not what. The diff already says what. 6 months from now, you'll want the reason, and only you have it. Then, the inline comments. You can leave a comment on a specific line in the diff, and it routes straight back to the agent that wrote it, as instruction. That closes the loop properly. You're not copying a line number into a chat box and describing where you are. The comment is attached to the code it's about. Concrete example. Agent adds a retry loop with no upper bound. You comment on that line. Cap this at 3 attempts and back off. That goes back with the surrounding code as context. Compare that with typing into a terminal pane. Fix the retry thing in the payments file. The agent then has to go find what you meant and might find the wrong retry thing. And you can leave several comments in one pass. Read the whole diff, mark the 3 things that bother you, send them together, rather than interrupting after every objection. That's a genuinely different working rhythm. It's code review as you do it with a colleague, on a pull request, in one sitting, instead of a conversation that never quite ends. Worth saying, nothing in here merges behind you. Reviewing is reading, staging is choosing, committing is you. 3 separate acts, and you're present for all 3. And the work tree structure is what makes reviewing calm rather than urgent. The agent's work sits on its own branch in its own directory. Nothing is pressing against your main checkout while you think. And the sidebar comes back. Behind the commit control, there's a verification gate. Before work merges, it runs your tests, runs lint, and runs a secret scan. 3 checks, and they're not advisory. Tests and lint you'd expect. The secret scan is the one people are surprised by. And it's there for a very boring, very real reason. An agent reading your codebase to fix a bug can, with perfectly good intentions, paste a key into a config file, a test fixture, or a debug print. It isn't malice, it's pattern matching. And a key in a commit is a key in your history, which is a genuinely tedious afternoon. Catching it at the gate rather than in a push is worth the few seconds it costs. This is also the mechanism behind the loop missions from Chapter 8. A mission cannot mark itself finished by asserting it's finished. A real check has to pass, or it goes back around. Which sounds like a small design detail, and is actually the whole difference between an autonomous loop you can leave alone and one that reports success at increasing volume. Then the guardrails underneath all of it, which apply to the agents as they work, not just at the end. 3 of them, and they're worth knowing by name. First, rights are confined to the repository. The agent works inside the project it was pointed at. It's not wandering into your home directory to be helpful about your .dot files. Good to see you, Claude Lab HQ. Fair point. The deck's got more open than it needs right now. Atlas, let's close the panes we're not using and drop back to the 2-pane layout, so people can actually read what's on screen. Second, destructive commands get rerouted to a recoverable trash rather than actually destroying anything. If an agent decides a file is unnecessary and it wasn't, that's recoverable rather than a story. Third, there's a snapshot before every action. So the question after a bad step isn't, can I get back? It's how far back do I want to go? Together, those turn agent mistakes from incidents into inconveniences, which matters enormously when you're running several at once, because the odds of at least one doing something daft go up with the count. There's also an egress filter that blocks cloud metadata endpoints and server-side request forgery, so an agent that's been fed something strange in a web page can't reach for machine credentials. And the thing that sits under all of it, this is local. The terminals, the editor, the diffs you're looking at, the board, the memory we'll get to next chapter, all on your machine. The only outbound traffic is your own agent CLIs talking to your own model provider, with your own key, exactly as they would in a bare terminal. Telemetry is off by default. So nothing here is proxying your code to be helpful. Your prompts don't route through us. The diffs stay on disk, which is the honest version of the safety story, and the one I'd want asked of me. Put the whole chapter in one line. Agents produce, the gate checks, the guardrails contain, and you decide what ships. Every one of those is a different job, and only the last one is yours. Atlas, take us to the memory room for the next part.
You're now in the memory room.
This is the memory room, and it is the least flashy screen in DeckSpace, and probably the one that changes your week the most. Notes on one side, a graph on the other. Everything we've built so far has had one quiet flaw. Chapter 6's Swarm, Chapter 7's Maestro, Chapter 8's Loop, brilliant, and every one of them starts each session with amnesia. You explain why the API client lives where it lives. The agent nods, does good work, finishes. Next morning, new session, and you are explaining the same thing to the same tool. That's not a model problem, it's a storage problem. The reasoning was fine. It just had nowhere to put the conclusion that outlived the conversation. So, this room is the place to put it. A folder of markdown notes that sits inside your project and gets read back in, session after session, instead of evaporating. Markdown matters here more than it sounds. These aren't rows in some opaque database you can only reach through this app. They're plain files you could open in any editor you own. Which means your notes survive DeckSpace. If you stopped using this tomorrow, you'd still have a folder of readable decisions about your own codebase. That's not nothing. The notes live in a folder called .opx memory in the repo. In the repo, deliberately. Memory about a project belongs to the project, not to some global account bucket. One consequence people like, it can go in Git. Your teammate clones the repo and gets the accumulated decisions with it, same as they get the code. Now, the thing that makes a pile of notes into something more useful than a pile of notes. Look at the double square brackets you'll see inside these notes. That's a wiki link. Write 2 open brackets, the name of another note, 2 closed brackets, and you've made a connection between them. That's the entire syntax. There isn't a second thing to learn. And that low ceremony is the point. Any format that demands you fill in fields and pick categories is a format you will abandon by Thursday. This one you can do mid-thought. So, a note about your auth flow links to the note about session storage, which links to the note about why you dropped a cookie approach. You didn't design that structure. Which is why the panel calls itself a knowledge graph rather than a notebook. A notebook is a list. This has edges, things pointing at other things. A wiki link pointing at a note you haven't written yet is fine, by the way. It isn't a broken link, it's a to-do, it marks something worth writing down later. I lean on that constantly. Halfway through writing about deployment, I'll bracket the name of a note about environment variables that doesn't exist, and move on without losing the thread. Worth being honest about the failure mode. Memory that nobody curates becomes a landfill, and an agent reading a landfill makes worse decisions than an agent reading nothing at all. Let me tuck the sidebar away. Clean view for this part. The other half of this room is the force-directed graph. Every note is a dot. Every wiki link is a line. And the layout settles itself by pushing and pulling until it stops moving. Nobody positions those dots. It's a physics simulation. Linked notes attract, unlinked notes repel. So the shape you end up looking at is a shape your links actually made. And you read structure off it in about 2 seconds, which is the whole reason it's here. A dot with a dozen lines into it is a load-bearing decision in your project. Clusters are the other tell. Tight knots mean a subsystem you've thought about hard. Lone dots drifting at the edge are notes you wrote once and never connected to anything. I use those orphans as a prompt. Either that note matters and I should link it into the rest, or it doesn't and I should delete it. Both are fine. Leaving it isn't. There's also a version of this graph you feel rather than see. When an agent asks a question you know you've answered before, that's a missing edge somewhere in here. So, what actually belongs in a note? This is where most people go wrong, and it's a short rule. Write down the things your code cannot tell you. Your code already says what it does. An agent can read it. What the code cannot say is why you chose this and rejected that, and what would break if someone undid it. Concretely, you tried a background queue for image processing. It fought with your deployment setup. You moved to inline processing with a size cap. That's a note. It's maybe 4 lines. Without it, some future agent looks at inline processing, thinks that's obviously wrong, helpfully refactors it back to a queue, and rediscovers your problem on your behalf. Same shape for conventions. Errors return a result type rather than throwing. This project uses one testing style. The database migrations are never edited after they ship. All cheap, all repeatedly forgotten. And project shape. What the modules are, which one is the entry point, where the risky code lives. New agent, new session. That's the orientation you'd otherwise type out again. What doesn't belong? Anything the repo already records. Don't paste your file tree in here. It's stale within a week, and it's a worse answer than actually looking. Don't put secrets in here either. It's plain markdown in your repo, possibly in Git. Treat it exactly as public as your source code, because that's what it is. Keep them short. A note that runs 3 paragraphs tends to be 2 notes that haven't separated yet, and 2 linked notes are more useful than 1 long one anyway. Like you'd say them out loud. Why we dropped the Q, not note 14. The name is the link text, so a good name makes the graph readable. And the sidebar comes back. Reading and writing happens 2 ways, and both matter. This panel is the manual one. You open it, you write a note, you edit one that's gone stale, you delete one that's wrong. That manual pass is worth protecting. 10 minutes at the end of a real session, writing down what you decided, buys back hours of re-explaining across the next month. The other way is that agents do it themselves. There are memory read and memory write tools, so an agent working in a pane can pull relevant notes in before it starts. And write them after. An agent that just spent an hour discovering how your build pipeline is wired can leave that behind as a note instead of taking it to the grave. which changes what the memory room is. It isn't your private notebook that agents happen to read. It's shared workspace. You write into it, they write into it. Both sides read it. Do keep an eye on what they write. Agents are enthusiastic note-takers, and enthusiastic is not the same as correct. A wrong note is worse than a missing one because it's confident. That's really the discipline of this whole room. Write the durable things, delete what turns out to be false, and don't let it grow into a wall of text nobody reads. Now, the part people miss, and it's the reason I'd put this room above most of the flashier ones. Memory ships with a self-hostable server, speaking MCP. MCP is the protocol agent tools use to reach outside themselves for context. Run this server, point your agent CLI at it, and that CLI reads and writes these same notes. So the value stops being trapped in one app. Your agent in a terminal outside DeckSpace on the same project gets the same decisions the graph in front of you shows. Think about what that fixes. Chapter 4's whole point was bring your own agents. This is the matching idea for context. Bring your own agents and share one memory between them. One project, one folder of decisions, and whichever tool you happen to be sitting in front of that day reads from it. You stopped maintaining several drifting copies of the same knowledge. And it composes with everything earlier in the course. A swarm's workers each read the same conventions. A Maestro reviewer knows the constraint you set 2 weeks ago without being told. Loop especially. Chapter 8's autonomous missions run long enough that context gets summarized away mid-flight. Durable notes are how a decision survives that, instead of quietly getting dropped. There's a self-hosting caveat worth saying plainly. That server is something you run, on your machine or your box. It's a small piece of setup, not a checkbox in this panel, which is the right trade for what it is. Your project's accumulated judgment isn't the thing you hand to a service and hope about. Self-hosted keeps it on hardware you control. So, Markdown you can read, links you can write mid-sentence, a graph that shows you which decisions carry weight, and a server that lets everything else read the same thing. One habit, if you take nothing else from this chapter: every time you catch yourself explaining something to an agent for the second time, stop and write it down here instead. This is the voice room. That's Atlas, the spoken assistant that ships with DeckSpace. It's the same workspace we've been in all course, just with a mouth and ears attached. Every other chapter has been about surfaces you drive with your hands: board, swarm, Maestro, review, memory. This one is about driving all of them without touching the trackpad. The first thing to understand: Atlas isn't a chatbot bolted onto the side. It's not answering questions about DeckSpace from a manual. It operates DeckSpace. Those are very different animals. The way that works is the whole app is exposed to it as a toolset. Every room, every pane action, every Git call, each one is a function the voice agent can actually invoke. The manual calls them the DS tools. Open a room, spawn an agent, list panes, read a pane's tail, create a task, move a task, run verification. That's why it can act and then answer out loud. It's not narrating an intention. It calls the tool, gets a real result back, and tells you what actually came back, which is the whole difference between an assistant and a demo. If Atlas says a pane is mid-question, it's because it read that pane's roster entry, not because it guessed. There's a rule baked into how it behaves too. For anything inside DeckSpace, it uses those DS tools, never generic screen clicking on DeckSpace's own window. That sounds like a technicality. It isn't. Clicking pixels is guesswork. Calling the app's own function is not. It's the difference between a colleague and someone waving at your monitor. So, the mental model I'd hold is you are talking to something with your hands. It has the same buttons you have. Not a subset, not a read-only view. Parity. The manual is explicit about that actually. Never refuse pane or workspace management. You have full parity with the user's own buttons. That line is written for Atlas, not for you. Which means the honest way to talk to it is like a colleague, not a command line. Right? Let's get the orchestrator open. Not execute open room orchestrator. It's a small thing, but it changes how it feels after an hour. You stop composing commands in your head and start just saying the thing you wanted. And when you say the thing you wanted, it maps to a tool. Open the board. That's a display call. It shows a surface. It doesn't start any agents. That distinction matters more than it sounds. Opening a room is display only. Spawning an agent is a separate, deliberate act. Nothing starts working because you looked at it. So you can wander the app by voice, out loud, mid-thought, without accidentally kicking off 8 agents on a repo you hadn't finished thinking about. Looking is free. Let me tuck the sidebar away. Clean view for this part. Let's go through what you genuinely say to it, in the order a real morning goes. It starts the way every morning starts. You want to see the work. Open the board. That's the Kanban we built in Chapter 5. Atlas calls the Room Open tool. The board comes up and it tells you it's open. One breath, done. Then, make me a task called Fix the Login Redirect. That's the Create Task tool. It writes a card to the same board you'd have dragged one onto by hand. Same store, same cards. There is no separate voice universe. Anything Atlas creates, you can see, drag, and edit yourself 30 seconds later with the mouse. Now the interesting one. Spawn Claude on the checkout bug. That's the Spawn Agent tool. One coding agent, one pane. Given a task in plain words. Remember Chapter 4. DeckSpace doesn't ship a model. So Spawn Claude means launch the Claude CLI you already installed and signed into. In a real terminal pane with your key. You can name the others the same way. Codex, Gemini, Aider. It's not translating your voice into a special agent. It's picking which CLI goes into which pane. And crucially, one agent. Spawn is singular. If what you want is several agents attacking one goal, that is a different sentence and a different tool entirely. Say, launch a swarm on this or get 4 agents on the migration, and Atlas reaches for the swarm tool instead, which is the Chapter 6 machinery. Isolated Git worktrees, a scout, a coordinator. That's worth saying slowly, because it's the thing the tool set is protecting you from. Asking for parallel work never quietly becomes 4 plain terminals in the same directory. The worktree isolation from Chapter 2 survives the voice layer. You said it out loud instead of clicking, and you still got separate checkouts. The idea doesn't get thinner by being spoken. Same with building something properly. If you say build this feature properly with review and tests, that's the orchestrate tool, Maestro from Chapter 7. Intake questions, a plan gate, workers, a reviewer. And Maestro's gates don't disappear because Atlas started it. It still asks its intake questions. It still wants your approval on the plan. Voice moves the paperwork. It doesn't skip it. Atlas relays those questions to you spoken. You answer spoken, and it feeds your answer back through the answer tool. The gate is intact. You just didn't have to type into it. Then, progress. What's Maestro doing? That's the status tool. And you get a spoken report instead of squinting at a room while you're making coffee. which is really the point of the whole chapter. The app hasn't gained abilities. It has gained a second way in, for the moments when your hands are busy. And the sidebar comes back. The other half of Atlas is not commanding. It's asking. And that turns out to be where it earns its place, because a deck of running agents is genuinely hard to read at a glance. What are the panes doing? That's the List Panes tool. You get the roster, every pane, what its agent was asked to do, its status, and importantly, whether it's asking you something. That last field is the good one. It's called asking. It's how a pane tells the roster it has stopped and is waiting on a human, rather than still grinding. Because that's the real failure mode of running several agents. Not a crash. A crash is loud. It's one pane that quietly asked a clarifying question 40 minutes ago, and has been sitting there ever since. So the habit worth building is, every so often, out loud, is anything waiting on me? And Atlas checks the roster and tells you. That is a 5-second question with a real answer. When one is waiting, you go deeper. Read me pane 2. That's the read tail tool, which pulls that pane's actual screen so Atlas can tell you what it asked. Say the agent stopped and asked whether to migrate the existing rows or start clean. Atlas reads that back to you. You now know the question without leaving whatever you were doing, and you answer it by voice. That's the Send to Pane tool. One message to one pane, answering that one agent. Migrate the existing rows. It types it in, the agent carries on. That loop, list, read, answer, is the thing I'd actually practice. It's how you supervise 4 agents while your hands are on a different keyboard entirely. Then the 2 verbs from Chapter 9, which are the ones I lean on hardest. Run verification. That's the verify tool, the real checks, tests, and lint, the gate that nothing self-certifies past. And Git. What's the Git status? That's the status tool. Straight answer, what's changed and what's staged. Atlas can commit too, but I still like reading a diff with my own eyes first, which is the same principle as ever. Voice speeds up the looking. It doesn't replace the deciding. You are still the one who says, this ships. Memory works the same way, incidentally. Atlas can read and write those notes from Chapter 10. So a decision you say out loud on a Tuesday is still there on Friday. One honest limit. What I can't tell you today is which parts of the listening run on your machine versus a service. That's on the open questions list, and Sammy will follow up properly. So, enough describing. The whole argument of this chapter is that it acts and then tells you what happened, and you shouldn't take my word for that. Let's ask it for something small and completely checkable. I'll ask Atlas to open the board, the rune from Chapter 5, and we'll see whether the rune comes up and what it says back. Atlas, open the boardroom for me.
You're now in the boardroom.
This is Helm, the panel you talk to, and where we're staying for the whole chapter. Everything from here on is the rest of the rail, the surfaces we haven't given their own hour. Start with skills. A skill is a packaged instruction set, a checklist, a house style, a deploy procedure that you hand to an agent instead of retyping the same paragraph every session. Why it exists. The second time you explain your commit message format to an agent, you've already lost. A skill is that explanation written once and reusable forever. The practical move is drag and drop. You can drag a skill straight onto a terminal pane, same as you drag a file in, and the agent picks it up as context. Concretely, You keep a skill that says how this repo does migrations. New agent, new pane, drag it on, and it stops inventing its own conventions in your database. Search. Code search is the plainest surface here and the one you'll use most without noticing. Find code across the workspace, then hand the result to whoever needs it. It matters more with agents than without. Before you spawn something on the off bug, you want to know there are 4 files touching off, not 1. So the task you write is honest. Atlas can drive that too. The manual is explicit that finding code is one of its tools. So asking out loud where something lives is a real path, not a party trick. Separate from workspace search. Search inside a single pane. Command F within a terminal. So you can go back through an agent's output and find the line where it explained itself. That is a genuinely underrated thing. Agents narrate a lot. The interesting sentence is usually 4 screens up, and scroll back plus your eyes is not a search strategy. Then, command history blocks. Every command you run becomes a clickable block in the pane, with a dot showing its exit code, succeeded or didn't. Why that's not decoration. In a busy pane, you lose the boundary between commands. The blocks give you the seam, and the dot tells you which one to go look at. So, the debugging loop becomes visual. Scan the column of dots, find the red one, click that block, read exactly that command's output instead of scrolling through everything around it. Themes. Last of the small stuff. There are a lot of them, and I'm not going to pretend that's a feature so much as a comfort. You stare at this for hours, but there is one real use. Theme a workspace so you know at a glance which one you're in. We covered workspaces earlier. Color is the cheapest possible way to not commit to the wrong repo. Let me tuck the sidebar away. Clean view for this part. The browser room is the next surface on the rail, and it's a browser inside the app. You preview what you're building without leaving the deck for a separate window. The part worth the chapter is Canvas. In the live preview, you click an element, describe the change you want in words, and an agent goes and edits the source behind it. That closes a gap that has annoyed everyone who has ever worked with an agent on a front end. You can see the wrong thing. Describing where it is takes longer than the fix. Concrete example. A button spacing is off. Instead of writing a paragraph about which component, which class, which file, you click the button and say, "Make this tighter." It's the same idea as the worktree idea in Chapter 2, honestly. Reduce the translation. The less you have to convert what you see into what the agent can find, the fewer wrong turns. Detachable panels are next. And this is the one that changes how the app feels on a second monitor. The browser, the editor, the board. Pop any of them into their own window, so the deck stays on one screen, full of panes, and the preview lives on the other. You watch the agent's work and watch the result at the same time. The layout is remembered per workspace. Set it up once for a project. Come back tomorrow, and it opens the way you left it, instead of making you rebuild the arrangement. Workflows is a room on the rail for the repeatable sequences, the things you do the same way every time, and would rather not reassemble from scratch on a Tuesday. Background jobs is where work that doesn't need a pane babysat shows up. Not every task deserves a terminal you're staring at, and this is the surface that says what's still running. The reason that surface exists at all. Once you've got several agents plus missions plus verification, forgetting something is running is the actual failure mode. Relay is the last room on that list. And here's the honest bit. It's not a surface I'm going to teach you from the seat of my pants and get right. What I do is what you do. Open it, read what it says it does, and try it on something small. That's a better answer than a confident wrong one on a live stream. Zoom out, and the pattern across all of these is the same. None of them are the headline. They're the friction removers that decide whether you actually use the headline features twice. Maestro and Swarm are why you'd download it. Command F, exit code dots, a preview on the second monitor, and a skill you dragged in once are why you'd still be using it in a month. And the sidebar comes back. So that's the whole deck from Helm here. Board for work as cards, Swarm for many agents on one goal, Maestro for building properly, Loop for autonomous missions, Review for reading the diff yourself, Memory so decisions stop evaporating between sessions, Voice so Atlas can operate all of it, and the surfaces we just walked. Under every one of them is Chapter 2, a Git worktree per agent. Separate checkout, separate working directory, so parallel agents edit the same project without landing on each other. That's the load-bearing idea. Terminal panes alone share one working directory, which is why stacking terminals gets you noise, and DeckSpace gets you parallelism. Everything else is built on top of that. The other thing to hold on to from Chapter 4. DeckSpace doesn't ship a model. Claude, Codex, Gemini, Aider, your CLIs, your keys, your sessions, running in real terminals. Which means the thing you're buying is the workspace, not the intelligence. It orchestrates agents rather than reinventing them, and your prompts go to your provider the way they already did. And it means you're never trapped. If the agent you prefer changes next quarter, it's still just a CLI on your path, and the deck around it doesn't care. How you get it. DeckSpace.dev. That's the download. Demo it and sell it as a macOS app. That's the platform I'll stand behind on air today. There's a 7-day free trial. It's card-gated, so you put a card on file to start it, and you can cancel any time inside those 7 days. I'm not going to read out prices or refund terms live. That's not mine to answer on a stream. The site's terms page has it, and Sammy will follow up on anything specific. What I would do with 7 days, pointed at a real repo you already know, not a toy. The whole value is in parallel work on a codebase you can judge. Day 1. Open the deck, put 2 different agents in 2 panes on the same project, and confirm for yourself that they aren't colliding. That's the claim. Go check it. Then run one small feature through Maestro and read the diff in review before anything merges. If you only test one loop, test that one. It's the shape of every good day in this app. And write 2 things into memory while you're at it. Come back the next session and see whether the agents still know them. That's the difference you're actually paying for. If you stop the course here, you have the complete picture. Every room, the idea underneath them, and how to get your hands on it. The chapters after this are sharpening, not filling gaps. Quick pause before we move on. If anything so far needs unpacking, drop it in chat right now, and I'll take it. That is the whole tour. DeckSpace is at DeckSpace.dev, macOS, and every plan opens with a 7-day free trial with a card on file. Cancel anytime. Everything we did today, you can do on your own repository within about 10